We're going to start at 12:03. Welcome, welcome. We're going to start at 12:03. Give it a couple more minutes. Welcome, folks. So we're going to go ahead and start at 12:03. So we're going to give it a couple more minutes. Erez, can you see my screen okay?
Yes, I can.
Perfect. All right, we'll start in 3 minutes. A lot of new names on the list. Happy to see that. And a lot of familiar ones too. All right, folks, we'll give it 2 more minutes and we'll get started. Get a glass of water, use the restroom if you need to, because we're going to take you on a journey for the next hour and a half. Andrea's here, welcome. Christina, nice to see you. Well, I can't really see you, but nice to see your name on the list. All right, 1 more minute and then we're going to go ahead and get started. All right, so it's 12:03. We're going to go ahead and get started. Thank you everybody for tuning in today. We're happy you can allocate some time on your calendar to join us. And I hope that everyone is staying safe and well during this pandemic. I'm coming at you from my virtual office in SoCal, and I'm a marketing and community manager at Nebula Works. My name is Anne, and I'm also going to be your host for today. I'll try to keep this session fun and also educational at the same time. With that being said, we're very excited to host another round of lightning talks. And we have two special guests with us today. But before we dive in, I'd like to briefly talk a little bit about Nebula Works and why we decided to create the Cloudnatives community for folks who are joining us for the first time. And I see on the list that there's a lot of new names. So welcome and thank you so much for being here today. All right, so who is Nebula Works? Just to give you a little background story, Nebula Works got started in 2014 by two engineers who had a vision that there was a need to challenge the status quo of how software was developed and delivered in enterprise IT. Now, at that time, enterprise consultancies were primarily tailored to delivering software solutions to the executive C-suite, with the engineers predominantly left behind. Nebula Works was founded to solve complex engineering challenges of the engineer. So effectively, we are a global system integrator and consultancy that was created for engineers by engineers. And we believe education is the first step to gaining team capabilities and business velocity. And that is why we created the Cloudnatives community. Now, this photo was taken back in January or February of this year, and we definitely have a lot of fun at our in-person events. So hopefully we can return to that when we go back to our regular cadence. So our Cloudnatives community is a platform for engineers to openly and safely discuss software development best practices, learn new tech, as well as share personal and professional experiences. We're always looking for new speakers. So if you're interested to present at an upcoming webinar, just shoot me an email and we can arrange something. So we currently have over 700 plus IT professionals in our community with two existing chapters. A lively one here in Irvine, SoCal, where our Nebula Works home office is based out of. And then a second chapter, which we launched this past January in Raleigh, North Carolina. If you'd like to keep up to date with our latest Cloudnatives webinars, feel free to join a chapter that is closest to you. Although everything is online right now, so either chapter would work for the time being. All right, so in addition to our Cloudnatives webinars, we also have a separate touch point when it comes to our online virtual events. And that would include our Nebula Works webinars. So what is the difference, you ask? Well, our Nebula Works webinars are focused on how we can help you and your team solve engineering challenges of building, testing, and maintaining cloud infrastructure by leveraging software development techniques. If you'd like to learn more, I'll share a link to our upcoming webinar on May 21st, shortly in the chat. All righty, so next I would like to introduce our two guest speakers for today's lightning talk session. I'm sure all of you are very excited to hear from them both. Our first speaker is Jahn. He is a technical manager and DevOps advocate at Dynatrace. Over there, he shapes strategic technology partner roadmaps with the latest tech companies. He also leads technical workshops and is a frequent speaker and blogger. Now, fun fact, Rob, what is your fun fact? We want to tell everybody?
Well, one, I guess fun fact, I am dialing in from Boston. So I guess that's a fun fact. So I'm not, so with our virtual world, anyone can be anywhere. But I have a connection to to California. I went to high school in Folsom, so not too far away, but I feel like I'm Californian in at least one aspect of myself.
Woohoo, there you go, awesome. Well, welcome. Next up, we have Erez Schwarz. He is a solutions architect of the West at Aqua Security for over 3+ years now, and he works there to educate organizations on the importance of cloud-native security and help them improve the security through DevSecOps. Fun fact, he's lived in 6 different countries. Erez, you want to tell everybody what the 6 different countries are?
Yeah, it's I grew up in London. I moved to Israel. Then I moved to the States, to DC, and then I moved to Africa. and worked in South Africa and Sierra Leone. And then I moved to Japan and then moved to San Francisco. So yeah, a lot of places.
All over, I love it. I want to visit London, South Africa, and Japan. Definitely, those are my list. So once this is all over, I gotta visit. Well, thank you so much for joining us today. And before I pass it over to Rob, our first speaker, I just want to let everyone know that we want this to be a highly interactive session. So if you have a question during Rob or Erez presentation, feel free to utilize the hand raising feature found on the bottom center of the Zoom interface. And then once we see that, we'll unmute you and then you can verbally ask the question. Other than that, I'll pass it over to Rob to take it from here. I'll go ahead and stop my share.
Great, so I'll share my screen.
Yep.
Right, so thank you. Yeah, so today, my talk is about embracing service levels within your pipelines. And so what we're seeing is, and I'm going to walk through this, is really that we want to prevent bad code from getting into production. And we want to do this in a continuous basis. And so how do we go about that? And what I'm going to talk about today is really kind of our motivation, with that Dynatrace, and really what I'm going to be talking about is an open source project, which is pronounced Captain. So it's KEPTN, but it's pronounced Captain, which is a platform in which we've implemented a number of use cases for kind of cloud native applications, including these automatic service level validation and what we call quality gates. And I'm going to get into that. And then I'm going to do some live demos. So hopefully that'll go well. And I've implemented in Bitbucket, I've been working with Atlassian as one of our partners to kind of learn around their platform. So I'm actually using Bitbucket pipelines, for kind of the demo today. So just a quickie kind of background is, we're moving to a world of more microservices, going from monolithic applications. And this in turn is kind of driving a lot more of, wanting to do things earlier, shifting left, not both functionally, but also with performance. So in the past, traditional apps may have taken weeks, months to deliver, and we did a big bang performance test at the end. But we really want to do this earlier in the life cycle, whether it's an API test or microservices, and we can leverage a lot of things to make that happen. But what's kind of prevents us in a lot of ways right now, and let me just sort of, I don't know if you see this meeting control, I'm going to hide that. A lot of times we can deliver the code, or a lot of times it's disconnected from our pipeline. So often we have one group that builds the code, deploys it, but then another group actually tests it. Or if it even isn't a pipeline, you can get your results and you're going through trying to figure out, what are the trends been build to build, what is my performance, trying to compare it across the builds, trying to, there's a lot of data to review. So these are kind of obstacles to really delivering, performance testing quickly through your process. So what we wanted to do is really take a look at what is someone doing. A human is now looking at these types of, metrics and objectives of a test. But what we're trying to do is get rid of the human and try to do these things in an automated way. And it doesn't mean that it can be fully automated. If there is an exception, we obviously have to triage and figure out what it is. But if you're doing continuous builds every day and you could have many, many microservices, it's just not going to be efficient for someone to actually inspect every single test. So what would happen is you may not test it at all. So we want to change that. So one inspiration that we've had, I think this is, if you haven't checked this out, this is a very kind of reference book out there. It's actually free. Here's the URL. You can Google search it. But in there's a whole section around this topic of service level indicators and service level objectives. So you're going to hear me talk about that throughout the day because that sort of was inspiration for us to kind of try to characterize things in terms of what's the data I want to get, and then for a given service to actually quantify that within the sort of range or boundaries that is acceptable. So what we're going to ultimately show you how we implement it with Captain, but conceptually, we want to take these files, codify them, have them declarative, retrieve the data from some source, calculate a score, and then determine if that's acceptable criteria. So this is the concept. Hopefully that's kind of makes sense. And then how it gets implemented in pipelines, we've seen people do it. So this is not a new concept. People have been scoring things, and actually AquaSec, is one of the idea of building in security checks, functional tests, unit tests. Conceptually, it's nothing new. We're just extending it to the next level. So we've had one of our customers was at PayPal, and they implemented this idea of like taking the metrics even further, where I have a JIRA ticket, I want performance feedback, I can submit my ticket, have it automatically picked up in a queue, spin up my performance and test environment. That's what RunDeck is. It's an automation tool. And then we can pull data from Dynatrace. We can run our JMeter test and then reattach that back to my ticket. So it's a really fully self-service kind of automated way. And that gets right to the developer. And that cycle time can go from, now you're getting results hopefully within, half an hour or less. Another inspiration for us was internally to Dynatrace, we offer a SaaS platform. So internally, we're continuously building and testing. So internally, we came up, this is Thomas, who I'm giving credit to within our DevOps team, has implemented these automated tests, comparing things build to build, taking a look at a lot of metrics and comparing them to previous builds to make sure within tolerance. So with that kind of said, I'm going kind of fast so I can get into the demo part. But so Captain then is, as I mentioned earlier, and here's the website up on the top right. So this is an open source project that we've been building, which is trying to establish a platform that can do cloud native type things, blue-green deployments, automating the validations between stages. We can orchestrate, or really choreograph is the word we use, choreograph the activities that are taking place through events. So instead of a rigid constructed pipeline code like a Jenkins file, we now have an event-driven control plane that has a standard communication, which then allows us to swap in different tools that do different things. So if I want JMeter one day and then I want to switch to, say, BlazeMeter in the cloud, I can do that because now all of my choreography is done through events. So I can swap tools in and out and integrate things in a very powerful way. So that's kind of what Captain is in a nutshell. I'm not going to get into a ton of detail of that, other than we're going to demo one aspect of Captain, which is this automated validation. And there is the two use cases that I'm going to walk through today. So one is this SLO validation. So by having a service level objective, I as a developer can kind of push this in for a request to say, start an evaluation for this time frame for my service with my objectives, feed it into Captain, let Captain pull the data from the various data sources, come back, calculate a score, give that back to the person that requested it. And then our second use case is what we're calling performance as a self-service, which is what I kind of showed a couple slides back, where I can say, Captain, I just completed my deployment. And that's kind of how I can tell Captain, let's go ahead and run my tests. So when the deployment completes, but I can kind of bypass the deployment part and say, let's just pretend I have an event, my deployment's done, I run my tests, I let it, then Captain will say test complete. The evaluation service will automatically pick that up and then perform that scoring and then send that answer back. So that's what I'm going to show. So let's just run into that demo, but let me actually have one more slide to show you the setup on my demo. So in my case, I have Bitbucket pipelines for Atlassian, which I'll show you. Maybe you've never seen that. And so we're going to check in our code, which then our pipeline is going to build and push our image. It's going to deploy our code. In my case, the application is a single containerized service running on Kubernetes. It's going to run a performance test, and then I'm going to have it call this quality gate, and then it's going to determine if I pass, fail. And then if it passes, it's going to push it on into my production environment where I could implement another quality gate. So quality gates aren't limited to just a performance test. It could also be after I do deployment in production, some real user traffic is maybe taking place. And so my service level objectives may be looking at different metrics than I might have been in my testing cycle. All right, so with that said, let me just jump over to my environment. So all this code is open source, it's available, all the links are at the end, so don't worry about it. But in Bitbucket, which is a SaaS-based pipelining tool from Atlassian, I now have a project out here, which is a simple application. So you see, it's not much more than a hello world, but it is a Dockerized app, which looks like this. And then built into the application are kind of versions. So if I tell it to run with a particular version, version 1 will be no issues. Version 2 will have some errors, and that's what we're going to capture with our quality gate. And then I can revert it back to version 4 with no issues. And so in my environment, I have a staging and a production Kubernetes namespace, which allows me to have kind of 2 instances of the app. And so what I have here is just a screen that's rendering both versions of the app in my staging environment and my production environment. And so what I'm going to do now is trigger our pipeline by making a change in my code. So here's my code locally, and I'm going to change this to version 2. So this is one of the files that's in the app, and it's just the nature of this app that will, you know, by me setting this version for demo, the internals of the app will, you know, perform this problem of error rates. And so now I push my code up to Bitbucket. So let me go back to Bitbucket. So similar to many pipelining tools, there can be an automatic trigger by checking in my code. So you can see here, it's just started a few seconds ago. This is my commit message. Let me click on the pipeline. And now you can see the pipeline executing. So there's a series, and I'm not going to get into all the details of the code behind the pipeline. You're welcome to look at it. The code is in a YAML file, but this now code is executing those steps that I kind of displayed on the screen. So this will take a minute or two to run. We'll kind of monitor, and we should see that this will switch to version 2. The quality gate should prevent it from moving into production. That's kind of this quick little demo. But let me just go back to the PowerPoint slide and kind of explain what's happening technically, and also to show you the specification that we kind of defined in Captain, and we're getting, you know, kind of feedback from community members that are joining the Captain community. So high level, as I mentioned, SLOs and SLIs. So the service level indicators are the things that you want to measure. So it could be response times, failure rates, you know, internal database calls. So, and then we want to have our objectives, which are in this range of a passing score and a warning score. And so you can see, like, response time, as long as I'm under 100 milliseconds, I'm good. If I'm below 250, I'm okay, but anything above 250 is going to be bad. And then as we add up all of our individual metrics, we can have an overall score, which is the sum of how each of these indicators resulted. So simulating, I had build 1. This is my actual scores. You can see for each metric. In this case, everything's within the green. I'm good. Here's another build comes along. You can see I'm within sort of the warning range. So overall, not enough for bad to make it fail. You can have another build. This one was a total failure, in that just the way the weighting worked, you get an overall failure. So this is kind of the idea. And then I could have a build 4 where everything's good again. Okay, how we implemented it is, again, there's a YAML-based file that defines your service level indicators. So this syntax is specific to the tool that you're gathering the data from. So the architecture of the Captain service is you can have service level indicator providers. So we've implemented a couple. We've actually had one of our community members, NeoLoad is a load testing tool, but this is idea that this can scale. So as long as you provide the data as an indicator, then you can put this definition into the service level indicator file. Then separately, you define your service level objectives to say, for my service, these are the things I want to measure. This is my criteria. And then as you start the evaluation, it will query this data from the data sources and then perform the score. So this is kind of how we've implemented it through this specification file, or 2 files rather. And then maybe just a little more detail, like what the file looks like. We have this concept of strategies on top of this. So I could look at a single result, like just let me look at the last data for the time range, or another strategy is the last X number of jobs. So I can have a continuous set of data that then gets calculated into an aggregated, like an average. So like my average of my last 3 good runs, use that as the basis of my comparison. So then when I have an objective like response time within this range, so here's my time series data, and if my value came in, I can also weight it. So if I'm 100, if I beat my target, then I get a full point. If I'm within my range, I get a half a point. And then if I below it, I get 0 points. And so if you have two indicators, this is kind of how it sums it up, you know, mathematically into it. And you can also weight something. So if you wanted this SQL statements to be more important than this one, you can also give it a little weighting on top of that to kind of, you know, influence the scoring. So this is what it did. So let's go back to our pipeline. It's probably further along here. And let's see where it is. I'm just going to hit refresh. So first of all, we've actually deployed it. So I'm going to go back to my app. So yeah, now you can see I'm in version 2. So version 2 is running in my staging environment. if I look back at my pipeline, it's now in the process of calling the quality gate. So it's completed the load test, it's completed the deployment. So now we can kind of watch this real time and let the drum roll here. And so how this is implemented, if you're wondering how the Captain quality gate got implemented, one of the features of Bitbucket pipelines is they have something where you can build what they call pipes, P-I-P-E-S, pipes. And what I've done is work with those guys to build a Captain quality gate pipe. And so what this is basically a Dockerized step that you can add into your pipeline. So all the logic is containerized. And so when you build your pipeline code, you can just say, call this pipe quality gate, provide the variables that you need. And now all the logic is kind of encapsulated within that step. And you can see there's sort of a community of these various things. So AWS has built stuff. So what I've done is take advantage of this framework and built this. So let's just see if it were okay. So actually good. So going back to the pipeline, the quality gate failed because it submitted the result. It went down through all the results, and now my evaluation failed because it failed on the error rate problem. And so this is a lot of JSON data to look at. So what Captain has is the ability to look at that in a web UI. So if I look at our, I thought I had this up. Let me pull this up. So Captain also comes with a UI for visualizing the events that are taking place in your environment. And then specifically for these service levels, we can see, is it refresh? We should see this particular entry. Loading, okay. So what would happen is in our event. Oh, well, let me show you one that failed earlier. That seems like there's a, so sorry about that. Looks like a little flaw in my demo here, but what happens is this bridge is letting you see the events that are taking place in Captain. So you can see a start evaluation event came in, it started retrieving the data. And of course you can click on it and see actually the real details. But then once the result comes back, you will be able to see visually the individual service metrics as they were calculated from the service. You can, there's also a heat map, which is actually showing each build as it's taking place. You can kind of chart it out. So this is kind of one of the features of Captain, to see the metrics as they come in all through this web UI. And then in this case, so our pipeline failed. So I'm going to re-kick it off just to show you back to version 4, which again will be a version that will pass because all the response time, the failure rates are back to normal. So we'll let that run in the background. And so let me move on to the next use case. So which is what we call performance as a service. Let me just do a quick time check. I think we're good. All right, and so what is performance as a self-service? So this is kind of taking it to another level where I just want to run, as I was showing earlier, get my performance feedback without having to rely on an offshore testing team, a bunch of other people. I want to do these things self-service. And so we're starting to, by incorporating pipelining, the quality gates, being able to have something like a Captain that can automatically work off these events to run your performance test, I can kind of get these, hopefully get towards these benefits. And we're seeing some of our customers doing just this. They're shifting from their, and it's a cultural change. It's not having a waterfall methodology, it's pushing back the performance requirements and definition testing back earlier into the life cycle, and then letting the performance team become the enablers. They can help you establish those service levels. They can help you set the guardrails. They can help, investigate performance problems. So because there's way more engineers than there is performance people. So we need to enable the performance engineer to do things self-service and not have to wait days and days and days for a result. So the demo I'm going to have is kind of showing it implemented using JIRA and there's a feature in JIRA, which is called automation. So they've added a new feature that was announced at the Atlassian Summit, where they actually acquired a company and built it into their core product to enable a lot of automation within the JIRA platform. So in my case, I'm invoking a REST call from the JIRA ticket to call Captain with this event. And then Captain is going to go ahead and choreograph these steps, including creating a new ticket that contains my results from the execution of whatever the quality gate determines. So
Hey, Rob, we have two questions, one from Matt and one from James. So Matt,
Okay.
I'll go ahead and unmute you real quick.
Thanks, Anne. So I just have a quick question about a slide that you mentioned earlier about the weight. Is the weight just like an arbitrary value that you just define yourself, or is there a meaning behind it? Like, is it like 1 to 10, 1 to 5? Like, is it just like what value are we?
Yeah, that's a great question. We went through we've gone actually through a couple iterations of this spec file. And so originally we actually required someone to come in and give it an actual weight, and it would be kind of up to you to decide this is worth 10 points, that was worth 20 points. But we concluded, just to make it easier, what happens is there's, like they said, there's kind of like this 1 point per indicator. And you can decide whether it's an information. So we have kind of some features. So there's like, if it's I just want to gather the data but not evaluate it, you can say this is an informational metric and it will not get included in the scoring. You can also add a weight, which basically doubles it. So in this case, there's 2 metrics, but I want, for the SQL one, I want to double it. So if you notice here on the bottom right, there's a total of 3. So in this case, I have, if I didn't use this weight, it would be a total of 2 and it'd be 1.1 point. In this case, I've said double the weighting. So now the SQL's worth 2 points, the other one's worth 1 point, but this top one in this example got a warning. So he only gets 50% of his points. And that's kind of how the math works. You could also like exclusively like a flag to say this is a key service level indicator, where if it fails, the whole thing fails. So you can force it to say like, I want, I'm making this up. If there's a failure rate above 2%, I don't care what the other ones were, it fails.
Gotcha. Yeah, that makes perfect sense. Thank you.
Yeah, no problem. And was there another question?
Yes, one more question from James.
Yeah, fire away. So it's on you, James.
James?
If you still remember your question.
James, you're
Right,
muted.
well, we'll come back to James. I guess.
Unmute.
All right, no worries. All right, so I will show you this now, the other scenario. So so here I have a JIRA board set up. Actually, this one popped from my last example. So let me just do it real time. So here I have a story, which is just test services. So built into JIRA, I've customized my, I don't know if everyone knows JIRA, but you can customize and add additional fields. So I kind of added these additional fields where I can kind of type in my value. And then built into this thing I was mentioning is called automation. So this automation is something in my case, I'm triggering it manually. So I'll just go ahead and let it rip. And it's going to execute here. What automation looks like though, I'll just kind of quickly demo that. So in JIRA automation, which is pretty powerful actually, I built a quality gate rule, which I'm saying, let it be manually triggered. And then what it's going to do is send a post request with this payload, which is the structure of the Captain event. So it wants the services, the stages, it's the Captain start evaluation event. And that's kind of what it does. But you can, but the automation is actually pretty powerful. So you can do, and I just kind of click on a couple things, but you can make it, create issues, you can run a bunch of stuff. So this is Atlassian's really way of automating a lot of workflows on the JIRA side, which has nothing to really do with Captain. This is just all out of the box Atlassian stuff. So if I go back to my board, by invoking it, because the evaluation is pretty quick, what happened is the result of the evaluation immediately came back and created a new JIRA ticket. So we were using in a Captain service, calling the Atlassian API to make a ticket and added all the stuff about what we wanted in this ticket. So the title is this automatic. here's my pass fail, here's my time range, and then I can have a link. So hopefully this will work this time. Click back on the Captain Bridge link, and it will jump because there's a deep link of the specific kind of invocation and step to see you know, that particular line, and then you can see the results here in the Captain Bridge. So if I go back to right, so that was the feature we did. So then if you notice it too, it also built a hyperlink, or what's called a linking the original story to kind of the subtask of, and you can see I've run it a few times, but see then that linkage automatically gets made. So this is kind of what we're trying to, so I was showing the quality gate, but I could also run, because it's just a different cloud event, the performance as a service. I'll just go ahead and run that because it won't hurt that I run that too. So that was the idea of self-service. So if I'm running a ticket, I just want to run a test, I can click it, let it go into my orchestration of Captain. Captain does all this stuff, sends everything back. Also, Captain, as an aside, what it was also doing is I have Microsoft Teams, so I have a notification service hooked up to Captain where, you know, as the events are taking place in Captain, it's also pushing these events, you know, into my chat tool as well, which is kind of cool. And then if we look back on our 2 frames, oh, there you go. So my pipeline, remember earlier I kicked off version 4, so you can see the quality gate passed, and now version 4 passed the gate, and it was able to push it on into production too.
Awesome. Rob, James is back with his question.
All right, James, all you.
Hey, Rob, can you hear me?
Yes, I can.
Cool. Yeah, all the automation stuff with the JIRA task looks amazing. I was just wondering how user-friendly is the implementation and getting this all set up?
That is a great question. And what is my time check? How much time do I have left?
So you have 10 more minutes.
Okay, good. All right, that's good. Because what I'll show you is, that's great. So I can show you some more details of things, but maybe as, and you can maybe take a screen grab of this if you guys are wanting, because I put some hyperlinks here. So one way to kind of get started and checking it out is the Captain website. So in there, it explains what the heck Captain is, why, you know, way more details about the different use cases and why. And this got recently built, which was, we had a lot of examples and tutorials, but the guys made, and when I say the guys, there's a team of 5 engineers full-time in Austria that are building the core Captain team within Dynatrace. And then we have a community where a lot of people from different companies and different people like Neotis and vendors and some SIs are all contributing to Captain. So all the source code is open. We have a really active Slack channel where people ask questions and get help. And then people are now starting to build out these different providers. So the easiest way to get started is, yeah, probably check out the tutorials. The Captain itself runs on so maybe since I have time, I'll just show you this picture too. This is sort of this is also in the docs, but this is a picture of the Captain architecture. And so what we are doing is, when you install Captain, it runs on Kubernetes, and it could be any flavor. It could be EKS, AKS, GKE. We also have it running on micro Kubernetes. One of the guys built a sort of a whole setup where you can install, it'll automatically install Captain on an EC2 instance running Kubernetes and run the whole thing. So we're trying to make it really easy for people to set up Captain and not fight that. But there's a CLI that kind of orchestrates a lot of the installation once you have your cluster set up. And then once it's there, you have both the CLI as well as an API. I'm using the API to get it into the Captain event control plane. And then it works on the distributor model within Kubernetes to then to work with the various services. So there's certain services that are kind of core to Captain, but the idea is all these things can be swappable. And so we're the next version of Captain where we'll implement this concept called a uniform, where you in a declarative file can say, these are the services I want, these are the parameters of the services, and just Captain apply this configuration, and Captain will just kind of do it. At the moment, there is, if you want to add services that aren't part of the core, you just have to kind of know some of the Kubernetes commands to kind of apply it's called a deployment config. So if you don't know Kubernetes, I won't get into throw out Kubernetes terminology, but anyway, right now you have to manually install some of the services yourself through Kubernetes commands, but the next version, we're trying to like abstract the installation and updating of services this way. And then Captain itself does more than just the quality gate. So what we've been demoing is I have basically the quality gate service, which we call the Lighthouse, as well as a JIRA service and a notification service installed in my environment. And that's all I need. So if you want just the quality gate, you just install the stuff related to quality gate. If you want Captain to run the whole deployment management from deploying things into your environment, running tests, etc., then it can also do that. But that's why I didn't want to get too much into Captain, but that's how you can learn with Captain. And there's a specific tutorial on quality gate only, if you will, to kind of follow that flow. And then what I have just as another, again, this is specific to Atlassian, but I just recently just put a blog out there on describing all this with all the hyperlinks to all this code. So this is another resource to kind of just learn about things. And then it may not be on the website, but we also put, we've been publishing things to.
Hey, Rob, can you send the link in chat so they can check it out?
Yeah, absolutely. Yeah. So then we've been publishing things to a Captain channel in Medium. So there's a lot of good articles that maybe, let me see if I can put that in the chat to everybody. There you go. So this is another resource to learn a little bit more about it. And then we also have, I'll put the link on here too, but in Captain, actually go to the website. So captain.sh. So on the main website, this link tutorials is what I was referring to. So you can come in here and say full tour. And again, it's not just Dynatrace. I don't want to make this a commercial with Dynatrace because we're trying to make this work with different data sources and different tools. So you can see if you just have Prometheus, which is another data source for Kubernetes, you can just use that. But the tutorials kind of walk through how to get started, blah, blah, blah. And then you can also join what we call our community meeting, which we present. Actually, today was a guy presenting on Jenkins integration earlier today. But the community page brings us to the GitHub repo. And in here, you can have all of the agenda for and I'll put this link in here too, for different meetings, all these. We have a YouTube channel. So there's a lot of ways you can learn about it. There you go. I don't know if there's any other questions. I don't want to take all the time up, but any other questions? You're free to throw them out there.
All right, Christina.
I will just put the last page up. You can grab a screen grab because that also has, this thing. This is kind of an easy. And I think, Ann, you're going to make all these slides available too for everybody. Right?
Rob, we have a question from Christina.
Okay.
Hi, can you all hear me?
Yes. Hi.
Okay, great. Hi, I have a couple of questions. So what you showed was a blue-green deployment. So my questions are, how does this work does it work with canary deployments? And also, is it dependent on service mesh? Do you need to have service mesh to integrate it?
Yeah, so I guess I'll answer it in two parts. So one, if you're interested in just the quality gate aspect of it, then it's just a REST call. So you can implement that REST call in any pipelining tool. And so in the community, like I said, someone built one for Jenkins. I built one for, as you can see, for Bitbucket Pipeline. People have done it for GitLab. So we probably have like 6, 7, 8 different examples, and with code that's all kind of in the sandbox. So we have a couple of GitHub repositories that people have put all this code that you can get examples and see how people implemented it. So that's kind of one answer. And then the other is, if you're looking for Captain to kind of choreograph deployments, Captain is how it's doing the deployments now is through Helm and Tiller. And it also has Istio installed as part of that too. So remember, Captain is not a product. It's been built up over time with a certain set of constraints to get it there. What's coming next is we're going to Helm 3.0, which will then eliminate the need for tiller. And then I think we have already a way to tell the installation of Captain whether you want it to install your Istio service mesh or if you have one existing on your existing cluster. So there's ways to install Captain itself depending on your Istio setup. We can maybe chat offline if you really want help to get it and answer some of those questions. But then in terms of integrating the Captain orchestration with other tools, that is where these services come in. So we have an example of, say, ServiceNow. So someone wrote a ServiceNow Captain service so that when you build one of these services, they can listen for these Captain events, and then Captain isn't doing the work. That becomes the integration back to whatever tool you want. So if it's like kickoff and a ServiceNow workflow, we also have people that have written an Ansible Tower workflow. So if Captain is like, do my configuration change, it invokes the service to whatever that is to actually do the work. And if that service reports back through the eventing that it performed it or had a failure, that's what informs back to Captain. So that's kind of the vision of it, is that, you know, it's Captain's not trying to be all that, but Captain is trying to then make the integration easier, so that what we're seeing is if people have, say, Jenkins pipelines and say have hundreds of pipelines out there, and now you want to say, oh, I want to integrate it with my Microsoft Teams and send notifications, I now have to edit maybe hundreds of pipeline scripts. So we always say, you know, the next legacy code is going to be the pipeline code. And so the real driver of this concept of event-driven service is that we can make integrations a lot easier to swap in and out without having to manage all the individual pipelining code. So we really want to abstract, you know, the deployment, abstract the testing, abstract the notifications, so that the developers just focus on writing the code and saying, hey, control plane, deploy it, right? And then that control plane through different strategies can ensure that things get done in a consistent way, and that can be governed and monitored, et cetera, from an enterprise point of view. So kind of a long answer, but hopefully that answered it. I hope.
Awesome.
Yeah.
Any other questions before we move on to Erez? All right, if you have any other questions, we'll allocate some time at the end of this webinar. But other than that, thank you so much, Rob, and Erez, you're next.
All right, thank you.
And a applause.
Yay.
There we go. Let me bring up my presentation. Rob, great job. Well done. That was interesting. Thank you.
Yeah, and the demo worked, so that's always good.
Yes.
I can't see my screen. I can't see anything.
We see your PowerPoint. It looks like it's your deck. It's just not in presentation mode. It's just in regular mode.
Yep. Oh, let's try that again. Maybe it just took so long. There we go. Yeah, it did. Okay. So let's start off. I'll just talk about Aqua. Aqua, we do cloud native security. And thank you, Anne, and Cloudnatives to give us this opportunity to sort of talk about us. A bit about me. I've been in security for 22 years, done all sorts of things. Earlier, Anne had mentioned that I've lived in a lot of places. I'm actually Israeli, but I've got this funny English accent, so please excuse me. And I've done all sorts of stuff. Talking about Aqua. So Aqua, we focus on cloud native security, and open source is really sort of a very, very important and critical part of who we are and what we do. The reason is because we think that open source validates the directions and what we see to be important. And so we put a hell of a lot of resources and effort into this. So just a few things about Aqua and what we do in the open source community and world and security in general. So one is, you may know Liz Rice. She is sort of famous. She's on the technical oversight committee for the CNCF. And basically she wrote together with Michael Hausenblas the book about Kubernetes security. She's just actually published a new book about container security. And you can see here a reference to a number of the various open source tools that we've published and made available. So CubeBench, KubeHunter, Trivy, CloudSploit. I'm going to get into what these are and what they mean in a bit more detail during the demo. If I go to the agenda, so basically I'm going to go over the various tools. I won't go over all of our open source tools because there is a long list and it's too much for today's presentation, but I'll focus in on sort of what I think is most important and most relevant. So if we look at this list, these are probably the three most important open source tools that we offer. The first being Trivy. Trivy is a scanning tool, allows you to statically scan container images. We'll see how this can be integrated with the CI/CD process. We have CubeBench, which is essentially a CIS benchmark for Kubernetes. CIS being the Center for Internet Security. And it basically checks your Kubernetes configuration according to industry standards. And KubeHunter, which is essentially a penetration testing tool, and it sort of tests your, I suppose, vulnerabilities from the outside. So KubeBench would be from the inside, KubeHunter would be from the outside. We have a lot more open source tools, but I'd just like to emphasize two, which probably I won't get too much time to speak about today. One is Tracy. Basically, as the name suggests, traces activity. If you're familiar with eBPF, extended Barclay packet filtering, basically it's a tool that allows you to monitor all activity within a container pod. And then CloudSploit. CloudSploit is this open source capability that we have. Very interesting in that it checks your cloud configuration. So all of the infrastructure configuration and the service configuration. So if you think of AWS and your key management, S3 buckets, the key management configuration of your databases, et cetera, et cetera. So all of the cloud configuration elements, it checks that, and it checks it through a system plugins. And in fact, all of those plugins are open source and they're freely available. They're actually available on this, you can see the address here, the github.com/CloudSploit. You can see them. You can go to CloudSploit, just Google CloudSploit, and basically enlist your cloud account and have it scanned. You can manually scan it, and it's all available, freely available. So very, very useful. Highly recommend it. I know all of us are behaving badly with regards to our cloud configurations and cloud security. So I know it will be very useful for everyone. So now I'm going to sort of go into a bit about Kubernetes and sort of how to secure the Kubernetes environment using those open source tools. Really, Kubernetes, Robert mentioned this earlier, but I mean, it's really sort of swept our industry, and it's sort of the main element, I think, or people are either moving to Kubernetes or have moved already. Of course, from our perspective, we're all about securing it. So just a quick note about the infrastructure and the components of Kubernetes. So you would have a master. Rob, you didn't want to go into this, but I'm going into it. And on the master, you have sort of very important components. You have a scheduler, a controller, etcd, which is in essence the database for the Kubernetes platform. And then you have an API server. And the API server talks to everyone, basically telling them what to do, giving instructions. It's really sort of the coordinator here. And then you have nodes, and on those nodes, you have a kubelet, which actually enforces the instructions of the controller and scheduler, and the proxy, which basically funnels all of the traffic and controls the traffic. And this is sort of earlier, Rob had been talking about service mesh, and sort of this is how network traffic is actually obfuscated within the Kubernetes environment and within the various pods and containers. So there are many different types of Kubernetes. There's GKE, there's EKS, AKS, there's IBM's version, there's Pivotal's version, there's the open source version, there's OpenShift. There are many different configurations to Kubernetes, and so really the way you install and what package you use is very specific. And do I have a question? Sorry, I don't know if I set the.
No, you're good.
Oh, okay, and so I'm going to quickly talk about CubeBench initially. So CubeBench is this open source tool which basically checks the configuration. If you're not familiar, the Center for Internet Security is really it's an initiative actually by the US government, funded by the US government, and it really defines standards of how things should be configured. So everything's there, everything you can imagine, from mobile phones to Ubuntu to Windows servers to everything. So one of the benchmarks is Kubernetes, and actually they worked with Aqua to define this, and we have basically open sourced this. It's freely available at the address that you can see here at the bottom of the screen. And it's really just a number of tests that we run on the Kubernetes environment. What I typically do is I use it, I run it as a pod. It can be run as a container, as a Docker container. Here you can actually see the way it's run. So basically on the GitHub link, basically there's a link to a YAML file, jobs.yaml, and basically you would run this as a Kubernetes pod, and then you access the logs. You can see the reference at the top of the page there, and then the output is this. You can see basically the various tests, and you can see whether the result is informational or if it's a fail. If it's a fail, you can actually see the details down here. So we then go through all of the details. And And so you can see if you meet sort of standards and whether you don't, basically. And it's all of those components that I just mentioned. So you can see tests relevant to the kube proxy and all of the other components, basically, that and many more configuration elements as well. So there are a lot of tests here, a lot of details. The next tool that I'd like to talk about is KubeHunter. KubeHunter essentially is a penetration testing tool. So if we think of KubeBench as being that component that's actually run on the particular node or master node within the Kubernetes infrastructure, KubeHunter would be run from outside, or actually as a pod inside, but as an external entity within the Kubernetes infrastructure. Again, you can see sort of the connections here, the links of where you can find it, again, on GitHub under the Aqua Security directory. And what you can do is actually get a report from a particular website that we have available. So basically you can see the details. So this is actually the low-down command line representation that we have. We have this table format. But if you want to see the reports, basically in sort of a nice user friendly format, then this is what you get if you point it at the website. But as I said, this is how you would see it in the command line. And essentially, the way you'd deploy this is, again, either as a Docker container, or as a Kubernetes container, or from your laptop, or from, let's say, your Windows machine, or your Mac, or Ubuntu machine. And basically, you can execute it remotely. So this is just something that I executed over the last few days, and my sort of, I think it was my GKE environment, or it might have been my AWS. Anyway, it's one of the environments, and you can see what it does is it identifies the endpoint, and if it's open and accessible. So you can see the etcd, the database, basically, the IP here and the port that it's listening on. You can see the API server. Remember, the API server is that component that actually speaks to all other components. So, of course, that's very problematic. You can see information disclosure about the version, about the environment. You can see the version of Kubernetes that has been disclosed here. And of course, from an attacking perspective, what that means is I just go to my nearest vulnerability database and see what the particular Kubernetes version is vulnerable to, and then I start my attacking.
All right, Erez, we got a question from Matt again.
Yeah, go ahead.
Hey, so you mentioned that you can utilize that one service to kind of security check your Kubernetes cluster by using the website. Can you clarify a little more on how that works? Like, is it like, do you just like grant access to them to remotely execute that service in your cluster, or how does it work exactly?
You basically point, there are flags within the command line, basically, that you can define that you want to use the website, and basically, if I remember rightly, I think you have to register with the website, and then it will post the findings there. But it is it will get posted to this, and it won't be visible to everyone, but we do have access to this, if that makes sense. Does that answer your question?
Yeah, for sure. I just wanted some clarification. Thank you.
Okay. Let's see. Going on to Trivy. So Trivy is,
Erez,
go ahead.
just a quick question. How long does it take to perform a scan? And is it typically invoked from pipelines? I know you kind of showed ways you can kind of manually trigger it off, but is that something typically how you recommend it to be implemented? And again, how long does it take to kind of run through one of these scans?
It's seconds. It's really, really fast. So, I mean, it's literally what I showed you is, I mean, it was almost instant. It was like 2 seconds, I think. It was very, very fast. And this is remote as well. So very, very fast. The way this would scan, this would be within either remotely. So remember, KubeHunter is designed to be sort of this external penetration tester. And so you're looking at the components, what ports are open, if they're disclosing information, what you can access remotely, okay? So it wouldn't be part of your pipeline. And the benchmark is sort of the configuration from inside the Kubernetes environment. And so that would actually be executed on the host or the particular node or worker node or Kubernetes master. What would be part of the pipeline is actually what I'm getting to here, which is the integration with Trivy. So Trivy is the scanner, and I just want to talk very quickly about scanning. So really, everyone in the container industry talks about scanning, but what they're really talking about is static scanning, which means that you open an image. An image essentially is a huge zip file, and you simply open it, and basically you look at all the files. The contents of the zip file is all files, and essentially you're taking a hash of each file and comparing it to a known vulnerability database. And if the hash matches, then you know that that particular file is vulnerable to a particular known vulnerability. So it's very limited in its capabilities. And you have other open source scanning solutions, the most famous of which is Claire. Some of you may be familiar with that. So Trivy belongs to that family. Now, there's a lot to be said about that, and I'm going to get into the details. We also have a commercial version of the scanner we call the Aqua scanner, and in contrast to static scanning, on the commercial side, what we do is dynamic threat analysis, or DTA. Basically, that's just looking at you're actually executing the image, so you're instantiating it, running it as a container, and see how it behaves. And here you can see an example, basically, of all of that activity. So when you statically scan, you're not always going to see what happens when it's actually instantiated, okay? And this is the example. You can see that basically there's a crypto miner in here on the right-hand side. I'm going to move on and talk about sort of the complexities of scanning and why it is so interesting and so intricate and has so many layers. So the first thing is everyone always talks about CVs. CV stands for Common Vulnerabilities and Exposures. And this is really standards set by two bodies which have now become almost synonymous with CVEs. One being MITRE, you might have heard of it. MITRE is actually a private organization, actually initially funded by the US government, and it has many representations all over the world, and it basically publishes CVEs. Then you have the NVD, the National Vulnerability Database, which is actually a US governmental entity, and it's sort of kept by, if I remember rightly, the Department of Homeland Security. And essentially what the CVE is it defines a framework to, one is to actually give a number or a identification for a vulnerability, and then scores it according to a particular framework. And what becomes so complicated and interesting about this is that there are discrepancies between the vendors here. So you can see some of the vendors and the National Vulnerability Database. So many a time they don't agree on what constitutes a vulnerability, or the scoring is very different, or they don't update each other. So there's a lot of discrepancies here, and they happen because actually there's no real established protocols and processes on how to define this. So the result is that it's a bit messy and not so straightforward and simple. And this is just an example. So here we have a CVE, and you can see at the top of the page that the National Vulnerability Database has basically defined that any of this particular package, which is the varnish HTTP cache, from 4.0.0 to 5.2.2 is actually vulnerable to this particular vulnerability, which is CVE 2017-8807. And so actually, when you look at the vendor, what you find is that actually they patched, so this is Debian, they patched 5.0.0. So in fact, what they're saying is anything above 5. And including 5.0.0 is not vulnerable. So if I just go back to that screen, this means that what the NVD is reporting is actually now not so right, okay? And this becomes very, very problematic when this is just one vendor, Debian, but as I showed you, there are many more vendors, and this behavior basically is replicated across all of them. And so what we do, and this is where we put a lot of effort into sort of analyzing, collecting the information, analyzing the information, checking it, cross-referencing, summarizing it, and making it available. And so this is the output to Trivy. And you can see, basically you get the information here. You can see the, if we look from left to right, we can see the vulnerability. You can see the severity level column. Then you can see the particular installed version in the particular image, and you can see the fixed version, and then the information. And as I say, the sort of real emphasis for us is accuracy. So basically, if you compare us, let's say, to other open source scanning tools like Claire, basically Claire, when you scan using Trivy and you scan using Claire, with Claire you will get a lot of vulnerabilities, and they will be somewhat inaccurate, somewhat irrelevant. The reasons that a lot of the vulnerabilities are irrelevant in Claire is that they also report on kernel level vulnerabilities. And of course, within a container image, the container doesn't use the kernel. The only thing that is relevant to the kernel is the host. Okay, so everything concerning basically kernel vulnerabilities is really noise. It's not relevant to the container image. And you know, there's a lot of other things to be said about that, but I'll just move on. Some of the capabilities of Trivy here, we'd seen. Oh, actually, I did want to say. So Trivy, basically, the way to use it, you can use it locally on a particular host. You would, let's say, on a particular host, you would mount the Docker socket. And then basically execute it, or you could use it on any, you know, you could use it on your laptop. You can, if your laptop's a Mac OS or an Ubuntu system, Red Hat, you know, you've got the different install packages, so you can use Yarn and apt-get for Ubuntu and Brew for Mac OS. So it's very easy to install. And here's the sort of different usage. So actually, go back to here again. Here you can see at the top of the page, sort of very easy, very simple usage. Basically, you execute it by calling Trivy, and once it's installed, and then you just give the image tag name. And this page basically shows you the different functionality. So you can see the usage of basically in this particular example, when the image has been saved as a tar file, basically you can define that and scan it in that way if you choose to. You can output the we saw in the previous screen that the default way to present results is in a table format. Well, you actually have different types of displays of formats that you can use to display the information. One being JSON, the other being a template. And really, you have, this is open source, and basically you can use any template. So if you go to the Trivy site on our GitHub, basically you'll see that some people have created templates for GitLab and Circle CI and Travis CI. If I remember rightly, GitLab has a very specific format of presenting results, and you have to abide by their conditions basically to present within that environment. You can also filter, you can do things like filtering by severities. If I go to the next screen, you've got other functionality capabilities. You can filter vulnerabilities by type. You can see there are different types of vulnerabilities. You can update the database. So essentially, we have a vulnerability database, and Trivy basically would pull from that information and use that database to check the known vulnerabilities. And then you can basically define, if you only are interested in a particular in specific contents and details of that database, so you can regulate it to what you're interested in. And you can also ignore certain elements. So one of the challenges of static scanning is a vendor may say, "Oh, I'm not going to fix this." So you can actually define that and include that flag within your scanning. Now, this is the part where basically you could integrate it with your CI/CD process. Essentially, one of the things that you can do with Trivy is you can define an exit code. So by default, the exit code would be 0. As you can see here, you can define a different exit code for different behaviors. So in the first line here, you can see that a severity high basically you're defining an exit code of 0. But for a severity of critical, you're defining an exit code of 1. And what that means is that during the build, within your build script, what you're going to do is you can focus in on that and basically fail the build if you have an exit code of 1. And so the developers would then be forced to go back, correct whatever critical vulnerability. So they basically look at the package that's available that corrects the particular vulnerability, add that to the build and rerun it. Okay, so that's essentially how you would integrate it. And the same goes for, you can see the 2 examples. And by the way, on the within GitLab, you can GitHub, sorry, you can see the various YAMLs that we offer, basically for the different integrations. I believe there's Circle CI, there's Travis, and GitLab, if I remember rightly.
Erez,
yes.
We have another question from Matt.
Yeah, go ahead, Matt.
Hey, so my question was about going back to your Trivia CLI. You mentioned that you can basically update the database accordingly to whatever you pass into its as a flag. Is it possible to have Trivia utilize, like, let's say, an offline database, so that way if you're using it in an environment where you may not want to have a constant internet connection or external connection, can you just have Trivia just utilize that and maybe update it every now and then?
Yes, you can. Yes, you can. So essentially, you would download basically the database. It would be offline and basically run it. And then once you want to update it, basically you would instruct it to do that. Yes. Yeah.
Gotcha. Okay. Thank you.
Okay. You can actually have a client server setup. So this is basically what you can see is you'd set up Trivia as a server and listening in on a particular port, and then you can have Trivia clients connecting into it. And so let's say you didn't want to have the client updated all the time, or you had some sort of security requirement of sort of being air-gapped or something different. Basically, you could possibly make the server available to being updated, and then only use the client and server connection internally. So you could do that, or one thing about the client server setup is sort of to scale to large scaling environments whereby you would have one server and many Trivia clients, and basically each client is its own machine or its own pod, and basically scanning, and so not using all of the resources of one server. You've got them spread out over different machines. So it's just a way of scaling basically for that. And then of course what you can see here is that you can introduce authentication so that it's done securely basically. Okay. I'm going to finish off. Anna, how much time do I have? I
will give you 5 more minutes.
Okay, cool. So I'll finish off just very quickly talking about the Aqua Enterprise, which is the commercial availability. And really that just includes all of the pieces that I've been talking about basically, and a bit more. So of course, we integrate with the CI/CD process. We actually integrate, typically it's Jenkins or GitLab or all of the different CI/CD tools that I mentioned earlier. Then you have things like functions as a service, things like Lambda. Azure functions, and then you have container as a service. So in those scenarios, this is more the runtime protection and Kubernetes security. And then we integrate with third-party vaulting vendors. So we have a secrets integration, management, administration capability as well, and integration with SIM tools and log management and log analytics tool. And the posture management, which I mentioned earlier, the Cloudsploit, has a commercial offering as well. So the runtime capabilities basically is an ability to learn the actual behavior of a container and then associate a policy to it. This screen just shows you that we learn all aspects of container behavior, so things like CPU usage, memory usage, executables, network connections, inbound and outbound, system calls, environment variables, user access, so you can control user access. All of those elements basically are in the commercial offering. And then basically things like drift prevention. Containers, if you don't know, have this notion and concept of immutable, meaning they should not be changed, but actually you can change them. And what we do with our runtime controls is make sure they don't, because we basically hash the contents of the image at build and then in registries and repos. And so then at runtime, we actually know exactly what's in the running container. And if anyone tries to upload, let's say, a malware or shellcode or an exploit to that running container, we can flag it and basically block it whilst the container is still up and running and fulfilling its business purpose. And then we have a container firewalling capability, and it learns the behavior. This can integrate with the service meshes and the CNI, the Kubernetes container network interface. This is just the integration with, this is the example of the integration with Jenkins, and now reports basically sent in Jenkins. So you have all of the various elements of that. Now everything is available on GitHub. All of the stuff that I talked about today, CubeBench, KubeHunter, Trivy, Tracy, and Cloudsploit. Highly encourage you to go there, have a look at it. I'll pause there and ask if there are any questions or.
Give it a couple of minutes.
Okay. So one of the questions that I get asked a lot is, what is the difference between the open source scanner and the commercial scanner? So there are just a lot more capabilities available on the commercial scanner. If you saw with Trivy, essentially what it's doing is it's looking at vulnerabilities. The commercial scanner, and it's only doing static scanning. In the commercial version, we do dynamic threat analysis. So we basically run the container and see its behavior. And then we do all sorts of other scans, like scanning the whether there are sensitive data in the image. If the image is configured to run as root, you can run custom scripts and tests on the image. So you have just a whole lot of more tests that you can run on the image itself.
Any other questions? Got a shy group here. You can also send it in chat.
Another thing that's sort of very interesting about I'd mentioned Tracy. Tracy earlier is this open source runtime tool which allows you to manage or to get visibility into what's happening within your container environment. And what it does is it utilizes eBPF, extended Berkeley packet filtering. This is a very interesting technology. It's essentially hooks into the kernel, the kernel of the particular host that is running the particular runtime environment, and gives you visibility into what's happening there. So if you think of the past, you may be familiar with sniffers and deep packet inspection. So Tracy would be sort of that equivalent, in that you're sort of going to see everything regarding a particular container or pod. And eBPF is a very, very powerful capability that sort of allows you to push all of the event data. Let's say if you execute an LS on the system, basically you're going to get a whole bunch of outputs, and you see all of the detailed information of what actually is being executed under the hood from a container perspective. And so, of course, that is part of the capabilities that we have in the enterprise and commercial offering. And how are we doing? How are we doing?
You're good.
Okay.
We're good. If there's no more other questions, we're going to go ahead and wrap it up. We'll give it one more minute.
So Cloudsploit is, just to talk about it, is another very, very powerful capability. Essentially, you would go just Google Cloudsploit. You can go to the Cloudsploit or the Aqua Cloud offering and just register there and basically scan your cloud accounts for configuration. You can do it for free. I highly recommend it because you will find, believe me, you will find things that you did not believe and think and forgotten, or and it's very, very useful. I think all of us have a tendency to use the cloud and sort of forget about things, and we've all done it where we've forgotten about security groups that leave certain ports open, and we have EC2 instances running and they're open to the world and they get compromised, etc., etc. So highly recommend you use Cloudsploit. And as I said, they have all of the tests are open source. All of them are available on GitHub, and you're welcome to add, edit, change the plugins. We call them plugins. So each test is named a plugin.
Awesome. So this looks like a good time to wrap it up. Rob, can you unmute yourself, and let's give Erez a round of applause. Thank you so much.
Yeah, thank you. Yep.
All right. So I'm sure our audience got a lot of great takeaways from both of your presentations. What are other ways they can connect with you? I know both of you have a LinkedIn profile. Were there other social media platforms that our audience can reach out to you at?
Sure. I mean, so LinkedIn is a great place. We can also, on the Captain, we have a Slack channel. So, if you join the Slack channel for Captain, I'm online with that. You can, what else can we do? I think on the Meetup website, I'm a member of meetup.com. So you can direct message people in Meetup. So any of the above, And I mean, you're welcome to email me too. Like my email is rob.jahn, JAHN @dynatrace.com. Send me that way too.
Send it in chat. Send it in chat. What about you, Erez?
I'm available at erez@aquasec.com. So anyone who wants to reach me on that. Also on LinkedIn, Erez Schwarz. So any of those channels, welcome to to reach out to me and talk.
There you go.
Awesome. Thank you so much for coming on today, Erez and Rob. And then Erez, if you can stop sharing, I want to share one more slide to wrap this up.
Should have gone over to you again. Is it?
All righty. So thank you so much, everyone, for staying on. If you stayed on till the end of this webinar, you are a trooper. Give yourselves a hand on the back. I just wanted to go ahead and share a couple more channels that you can connect with NebulaWorks. So the links are shared with you in the chat. The first one is our Cloudnatives Slack community. We actually launched that last month. So if you want to stay engaged with the community, ask questions, continue fostering these engaging conversations, feel free to check out the Slack community. We also have a NebulaWorks Insight page, which are all written content by our engineers on the latest industry trends, tools, and practices. We also have a YouTube channel where we have whiteboard videos that we release on a frequent basis. And we also have our previous recorded Cloudnatives webinars and presentations. So if you wanted to go watch a recap of the previous presentations, feel free to check that out. Then lastly, we also have our newsletter that we send out on a bi-weekly basis. So feel free to check out all 4 channels and also all the other links that Rob and Erez shared with you all today. Without any further information, I just want to say thank you so much, everybody, for joining us on this Zoom webinar. I know a lot of our events has been in person and that was super engaging, but we try to make this fun, even though it's a webinar. And then I'll see everyone at the next one. Thank you so much.
All right, thank you. Bye-bye.
Thanks, everyone.